Hi, in this session I'll cover Oracle TKPROF Fundamentals for SQL Tuning Part 2. This is the Part 2 of the video tutorial for Oracle TKPROF Fundamentals for SQL Tuning. In this part I'll be discussing about Introduction to Interpreting a TKPROF Report. I'll do basic interpretation of a TKPROF report. Okay. In the first part we have discussed about Introduction to SQL Tracing, set up SQL Trace and TKPROF and generate TKPROF report. Okay. In the part 2 we'll be covering interpreting TKPROF report. In the part 1 we have did hands-on to enable SQL tracing. We have visited various options to enable SQL tracing at session and DB level and generated a TKPROF report. In the part 2 we'll be interpreting a TKPROF report. Okay. So just to reminding why we need TKPROF and what is SQL tracing. Like SQL tracing is a low level tracing capability available in the Oracle database. It's a tool. Once you turn on SQL tracing, many vital execution statistics like in your query, number of logical IO, physical IO performed, number of the what is the CPU time and elapsed time, what is the number of rows processed, query plans with row count at each level, the actual query execution plan, okay, and the information of wait events. All these infos are written into trace file once you turn on the SQL tracing. Now as trace file got all these lots of tons of info, it becomes bit difficult to read. Using TKPROF you can generate a report from trace file which is bit easier to interpret. Okay, so this is the basic command for generating a TKPROF report. TKPROF, then give your trace file name, then give your TKPROF report file name, and you can use some options while generating TKPROF report like weights, specified whether to record summary for any weight event found in the trace file in your profiler report. That means if you set to yes, it will in your TKPROF report it will include the weight events. By default it's yes. Also it sorts the traced SQL statement in descending order of specified sort operation before listing them into output file, and explain it will generate a execution plan for each SQL statement in the trace file and writes those execution plan into output file, and TKPROF determines the execution plans if you issue this option by explain plan statement. But I will not use these options. I will go for the default options, and it will have all the vital details including the actual query execution plan. Okay, so let's first before enabling tracing I will set a trace file identifier. Suppose using this it will be easier to identify my trace file from the directory. Okay, now trace file identifier is set. My trace file name will came with this particular identifier. Now I'll set the time statistics to true, because if we don't set it to true then it will not record many vital details like CPU time and elapsed time and some other details. So we will set it to true. Then I will use dbms session trace enable. It will start the SQL tracing and waits true. That means it will record the wait event, and binds true will record the detail about bind variables. Then I will execute two SQL statement. One is insert, direct path insert, and another one will be a simple select statement. Then I will use dbms monitor dot session trace disable, or you can use dbms session dot session trace disable. You can use any of them to stop the tracing. Okay, tracing is done. Now you can see in the trace directory, this trace file is generated. If you open this, these are the details captured, execution details, but it's bit difficult to read out. Okay, let's generate a TKPROF report. TKPROF, then your trace file name, then your report file name, suppose tkreport.prf. okay, my report is generated in this path in the trace. Here you can see the TKPROF report. Okay, here all these details about execution details from this session are captured. Let's go to our insert statement. Yeah, this is the insert statement that we have executed in the session. Insert append into HR EMP DAPT, select this from these two tables where department ID less than 60. If you look into this, now these are the actual execution statistics. Okay, it shows each phase of the SQL statement like parse, execute and fetch. As it is a insert, in fetch you will not find any detail. If it was a select, then you will find details in the fetch part, cause in insert or update or anything like insert or update delete, you will not have this phase. Okay, in insert update it will not find fetch, you will find parse and execute. First part is parse, it shows the count as 1. Now what is parse? In this phase it defines that if Oracle has found the plan for the query in the shared pool or not. If it has found the query plan in the shared pool already, then it will be soft parse. Then, and otherwise if the query plan is not found in the shared pool, then it will be hard parse. Okay, so this is the parse count, number of parse. What is the time took to parse? This is the amount of time in second. CPU time, this is the elapsed time, and these are 0 in this step, disk, query, current and rows. Okay, and now execute. In this phase most of the tasks are done. Okay, most of the processing in case of this insert. Count, execute count 1. Okay, and what is the CPU time? 0.96. okay, and what is the elapsed time? 5.12 second, which is much larger than the CPU time. That means in this phase Oracle has waited due to some wait events, which we'll discuss here in this part. Okay, and disk 20,085. Here disk means physical reads. Okay, it means how much physical IO the query has performed. Okay, using physical read, Oracle reads the blocks from data file and places them into buffer cache. Okay, and physical read is always followed by logical IO that retrieves blocks from the buffer cache. Okay, here query. What does query mean? Query means the consistent read. This means how many logical IOs perform to retrieve consistent mode blocks. Consistent mode block means this can also include blocks reconstructed from the undo segment. Okay, and this will come, this is query is 20,104. These are number of logical IOs performed. These are the consistent mode logical IO. Okay, and current means how many logical IOs were performed to retrieve blocks as of right now, as of particular that timestamp. Okay, This will come in case of any you are doing a data manipulation operation such as insert, update, delete. Okay, in case of this insert, update or delete, a block is retrieved in current mode in order to process the modification. In case of a select query, Oracle retrieve the block as of the time that particular query begin. Okay, that's the difference. In case of a select statement, this will come as 0, the current will be 0. Okay, so these are the rows, number of rows processed in this phase, in execute phase. Okay, and here for insert, update, this will be 0. Okay, so in case of select statement, this in fetch part most of the processing will be done. So let's go to the particular select statement which have this all the steps in fetch, all the details in fetch. Here if you go to this, here you can see this is the query we fired, is select star from hr.mpl or employee id less than 300, order by this. Okay, here you can see most of the work is done in the fetch. Okay, fetch count, this is the fetch count. Okay, number of time, CPU time, elapsed time, this is very less cause it's a small query, just retrieve some 100 rows. Okay, this is the number of physical reads, this is the number of consistent reads. First physical read. Okay, and what I wanted to show here, you can see the current is 0. Okay, so no read in current mode. This will be in case of any DML like insert, update, delete, like that. And number of rows processed. Anyway, let's go to our insert one. This is the main statement that we will focus. Okay, so this was the execution statistics in case of this insert. Now we can see these are the summary details. What is the total count of parse, execute and fetch? 2. What is the total CPU time taken? 0.99 second. What is the elapsed time? 5.14 second. That means it has waited for some resources, as the elapsed time is much higher than the CPU time. This is the actual processing time, 0.99 second CPU time. Okay, this is the number of physical reads performed, number of consistent read performed, number of reads in current mode performed. Okay, and this is the number of rows processed. Now below that you can find a text, misses in library cache during parse equal to 1. What that means? That means the query plan is not found in the library cache of shared pool. That means it's doing a hard parse. The query plan was not in the shared pool in the library cache. It's not found there, so it is doing a hard parse. If it was a short parse, then it will not be there, like it will be 0, misses in library cache during parse. If in a session, if you execute this query twice, one after another, then you can assume that in second time, if there is no problem in your DB, it will do a soft parse in second time. And in case you will find, in case of the second, misses in library cache during parse 0. Okay, in case it is a hard parse, so it is 1. What is the optimizer mode? All rows. In Oracle 11g, by default it's all rows. What is the parsing user ID? From which user you are parsing that SQL? It's sys. Okay, now here is the actual execution plan, the row source operation. Okay, here you can see in the below, it's doing table access full for EMPL, and in these steps total 6,188 rows are fetched in this particular step. Okay, and just I just wanted to tell that this is the actual execution plan using which the query execution has occurred. And this is not any plan generated from explain plan or auto trace, and it will have some more details, like in each step how many rows have flowed out, in each step what is the number of consistent read, physical write, and lots of details are here. So here let's start reading it. So in this step it is doing a table access full for EMPL, that means a full table scan for EMPL. CR, that means the consistent reads, number of consistent reads, it's 20,089. PR, that means number of physical reads. Okay, how many blocks it reads from the data file into the buffer cache, that's the physical read, 20,078. First it reads from the data file. If you execute the query for the first time, if the data is not available in the buffer cache, first it perform the physical read from data file to read it to buffer cache, then it will do logical read from the SGA, and here CR is the consistent read. Okay, it is the second step after physical read. So first physical read is done, then our logical read in consistent mode is done here. Okay, and physical write, this is 0 in this step. Okay, what is the time spent? Okay, in milliseconds. What is the cost in this particular step? 5530. What is the size in bytes of this data that flowed out from this EMPL? Okay, what is the cardinality, number of rows? This is the cardinality, not exactly number of rows, but there is some equation regarding cardinality. Anyway, just keep this mind, this is card. Okay, and here you can see the actual number of rows. Okay, and in this step it's doing a index range scan of DEPT ID PK index. This index is on the department ID column of departments table. Here you can see number of rows flowed out 5 in this step. Here consistent read 1 physical write 0, time spent 4, cost 1. Okay, this is the second one, like from below it is the second step. Then it's accessing, the access method or department table is using access by index row ID. Okay, using that DPT ID PK index. In this step, number of rows fetched from DPT department table 5. Okay, number of, these are the number of consistent read in this step, number of physical read, amount of time spent, what is the cost for accessing this table department, what is the size in bytes, that amount of data that flowed out from departments table, and the cardinality. Okay, and after this, after getting the data from EMPL and DEPT, okay, it's doing a hash join to join the two data sets and to retrieve our data. In this step, this is the number of rows flowed out, this is the consistent reads 20,091, this is the physical reads, these are cumulatives. Okay, these things. Okay, and physical write is also 0, amount of time spent, what is the cost in this step, you can see 5535. Okay, and what is the size in bytes. Okay, and also the cardinality. And in the last step it's doing load as select, that means it's a direct path load. If you delete that append hint, then it will be conventional load. Okay, and in this part it shows all the details, and along with that it has one another thing, PW, which was 0 in all other steps. It shows 3842. This is number of physical writes. Okay, and now in below the row source operations you can find the wait event details. What are the wait events? Number of times waited, what is the maximum time waited, what is the total time waited. You can see from here DB file sequential read is have taken most of the time, 4.09 second. Okay, and then it also waited for like most of the number of times, also 175 time. Okay, now we'll discuss a bit about this briefly about this wait events, just basics only. Okay, so what we're discussing, like you can see these wait events. Like first we will discuss about direct path scattered read, as this have taken most of the time. So when this wait event basically happens, this DB file scattered read, when Oracle is reading multiple blocks from the data file. Scattered read is usually multi-block read. Okay, this event signifies that a user process is reading buffers into SGA buffer cache and waiting for a physical IO to return. A DB file scattered read issues a scattered read to read the data into multiple discontinuous memory locations. Okay, it generally happens when you are doing a full table scan. Okay, in most of the cases when you are performing a full table scan into the buffer cache, the blocks are read into memory locations that are not physically adjacent to each other. Okay, in such cases DB file scattered read wait event can happen. Okay, because the blocks are scattered throughout. Okay, mainly in case of full table scan it happens. Also it can happen in case of index fast full scan. Whenever you are doing a multi-block read, it can happen. Okay, and the another one, DB file sequential read. Okay, this event signifies that the Oracle is reading buffer into the SG buffer cache and waiting for a physical IO to return. It happens when you are doing a single block read. It is similar to scattered read, but the difference is scattered read happens when you are doing a multi-block read. Sequential happens when you do a single block read. Okay, and this often happens while you are doing a index scan. You are using indexes. Okay, also in some cases full table scans also could get single block due to the extend boundaries. These are very rare cases, but in most of the cases while you are using indexes you will have single block reads, and in this case you may find out that you are facing DB file sequential read wait event. Okay, and then there is disk file operations IO. This is a wait event, not a like very harmful or something. This wait event can happen when Oracle waits for any disk file operations. Okay, Like for example, like Oracle makes a call to data file for some read operation, and in this case a new call open is made to open the data file. Okay, for things like that, waiting for anything related to disk file operation, like file open or close, anything like that, this particular wait event disk file operation IO can happen. Okay, then the another one, direct path write. Okay, this direct path write wait event happens when you are doing a direct path load or any parallel DML like that. Basically, in our case we are doing a insert append using the append hint. That means it's a direct path load. When we do a direct path load, it writes data directly from the PGA to the data files. It bypasses the buffer cache. For scenario like this kind of wait event like direct path write can happen. You are writing from PGA directly to the data files. That is the direct path write. Okay, in case of CTAS operation like create table as select, insert append statement like insert with append, or inserts with like parallel DML, this can cause direct path write wait event. Okay, and also there is a similar kind of wait event, direct path write temp. Like while you are doing a order by in your SQL query, or you are doing some hash join, and mostly in case of order by, like order by is done, the sorting is done in the sort area of PGA. When the PGA becomes full, it writes pages out some of the sorted data into the temp table space to make it free. Like if it is a big query and your sort area is not big enough, then it sorts some amounts and then writes it to the directly to the temp table space. And this is also like from PGA directly written into temp table space. In this case, you can get a wait event called direct path write temp, because writing into temp getting waited for something. Okay, but it was direct path write. It was a close similar kind of wait event, direct path write temp, while you are doing any sorting operations. Okay, and SQL net message to client and SQL net message from client. This two wait event happens when your some request is going through going from the client to your Oracle server. Suppose you are executing a SQL query and which fetching data using network from your Oracle server, or simple. In this kind of scenarios, these wait events can happen, and they are also not very harmful. Okay, so these are the basics of interpreting Oracle TKPROF report. In this section I have tried to cover just the basic overview. Also there are many much details. Okay, so thanks for joining my session. Hope you will like it. Thank you.